Let's get started. Hi, I'm Konstantin. For the last few years, I have been developing JavaScript and continuous integration systems and automation. Last year, I joined Facebook React Native team. And before I start, let me ask the audience, is there anyone who develops iOS applications? Nice. Anyone developing Android? Better. BlackBerry? Anyone here enjoys JavaScript development? Awesome. So, when I joined Facebook last year, my beard was shorter, my body mass was less, and I was a joyful character. At Facebook, when you join, there is a bootcamp program. It's something that you're thrown into action right from the second day of your work, and you start fixing bugs and implementing small features. And everyone does that, managers, engineers. And there is a good chance that a week after you started, 1 billion devices will have your contribution. And it makes you feel good. So I remember very well my first task. It was a popular Android application. And there was a piece with map view, and below it there was a label. So the line between label and the map view was a little bit too thin to be considered aesthetical. So my task was to make the line wider. The code looks something like this. It's an UI component XML declaration, how you do it in Android. Don't look at the code, it's just an example. So the idea is I check out the code. We have a large mono repository at Facebook. I compile it, a couple of hours pass. Finally, I can run it on a device. I found the code that I need to change just one value, just from 1 pixel to 2 pixels, and then I want to run it again. You know how much it took me to do? 114 seconds. Yep. And can you guess, did I fix it from the first moment? No. The problem is there are rounded corners and there are boxes around. I can't just increase the width of a line in Android in one place. So I was doing it more and more, and eventually, after many, many iterations, I did it. And I think it's not good. It's not something what a web developer, which I was considering myself, is used to, waiting for minutes for your change to appear. And the thing is that modern development is all about iterations. You have the product owner and you have a developer, and they have a tight relationship, changing the UI iteratively. And it's not only about iterations in UI development. Look at the Viking. He says that you lose ability to deliver development if your iterations are interrupted. And it's everywhere. It's not only about building your UI, it's also about building your application or delivering your product if we are talking about continuous delivery that a lot of companies do now. So this is what my talk is about. It's about iterations. On the level of iterating UI development, compiling your native code, and also continuously delivering the product. So when I talk that I work for React Native, a lot of people ask me, is it something like PhoneGap? Or better say, is it something like a browser running a React application, and then you just show a website instead of a real app? Well, actually, it's not. If you open a React Native application and inspect it inside, you don't see any webby stuff. You see real native components. But before talking about React Native, we need to refresh our memory on React first. Anyone here worked with React? All right, not everyone. So imagine a very simple component, a like button that toggles. You like something, it becomes blue. You click it again, it becomes gray. In the old imperative way, it would be something like that. If a user likes this, and if there is no blue icon on the screen, remove the gray icon, and add the blue icon. This code is focused on transitions between states. Right now, it's only one state, only two states we have here. When we have more states, the code becomes more and more complex. React Native way, the declarative way, is to focus on UI itself for a given state. Now you might think, all right, there is a trick somewhere. Before, our code was a little bit smarter. It was actually transitioning between states. But now we're talking about the states. Where are the transitions? That's what React does. It automatically calculates the minimum change that is needed to transition from one state to another. And it's very fast because it does it in memory. For example, you have a blue icon, and then you go to a gray icon. It keeps in memory what was the previous state, knows what is in the current state, and does everything for you. React Native brings React to development for iOS, Android, and now Windows phones, and also Tizen. So let me show you a small demonstration of how React Native works. We have a simple component, the same toggle type of thing that I told you before on the left, and we have an Android device on the right. The component is simple. You have a getInitialState function, and it defines the initial state of your component, and it's just a Boolean flag, on or off. There is a render function. It is called every time the state changes. And there is a handle press callback. You see it in the render being called. So if we try it, user taps something, it goes on, off, on, off. I just want to repeat, React Native is not about DOM. It's not about WebView. It's all happening with real native components. React Native is about running JavaScript with React in parallel with the main thread that renders your UI. Now, when people hear JavaScript and they are native developers, sometimes they react like this. It is slow, it is interpreted, garbage collected. Well, first thing, it's not slow. Second, it's interpreted. And that's very good. Because once you interpret a program, you can reinterpret pieces of it. Let me give you a demonstration. This is a slightly more complex application. This is a component that defines the whole screen. And I'll show you something that's called hot module reloading. What it means is, code on the left, you type your code changes, it gets compiled and sent to the device that is already running a React Native app. And because React recommends you not to store state in the components, the state lives somewhere in JavaScript in memory, not in the components themselves. They are basically pure functions. You can replace the component while the application is running because you don't break your state. You don't break your current situation in your application. And it means that you can replace the definition of component, call render again, and you have your changes live on the application. If you make a mistake and something doesn't compile, you see a red screen, but you can fix it and it gets fixed. So let's go next. So now we come to a synergy of product owner and the developer. We can finally have the perfect way of developing. Product owner tells you what to do, developer does. Everyone is happy. So you might be thinking, all right, let's try this maybe sometimes in the next project, years later, because I have something to deliver right now. I don't have time to mess around with new features. I have a project to do. Well, how about now? The thing is that React Native works extremely well with pure native applications. If you see here, it is an iOS application, purely native. On the left, it is Objective-C code that I cannot read. But according to lines, there is all the things that are written on the left are actually rendered on the right. So when you're navigating, when you click on these elements in the list view, you see a new native view. But What is in the gray is actually a React Native view. And it is the same as React Native application. It follows the same rules. You can live edit it and do everything about interpreting the new UI. So my call to action is get to the chopper of fast development now. So let's see where we're moving on our iteration. Bug. So sometimes you need to compile your native code. Even React Native applications need to be compiled. And this is a big issue. This is something Facebook has tackled. If you are running, if you're building an Android application, most likely you're running Gradle. Gradle is amazing, don't get me wrong. It gets you started very fast. It has integration with Java ecosystem, all the open source libraries. You have a great scripting language for your build system, for your build configuration. And it is much better than just Java or XML, because they are not supposed to be used for your build configuration. And it's been open source and it's been around for quite a long time. So actually, you can find solutions to common problems on Stack Overflow. But when you go into your project, when you start working on it, as the time goes, the code base gets larger. And the larger code base, the slower your build. Now, all the features that I told you before, they're not that important anymore. What is really important for you as developers is how fast you can iterate on your building. And Bug was built when there were other tools already existing, because there was a need to make fast builds. And it made a lot of hacks and tricks and very well made design to make it fast. Most of it is done by well-implemented caches. So maybe now you will expect me that I will start comparing Bug to some other building tool. That I will bore you with some tables, with green values, that many % win. Well, actually, you're right. Why else would I be here? So there is an open source Android application. It's been designed for Gradle. It was optimized for Gradle. And people at Bug team, opinionated, but still, built it with Bug and optimized, made simple optimization to work with Bug. And here is you see that at different levels of build steps, at different build steps, you have different changes. Sometimes it doesn't look too much, but for a developer, 13 seconds and 2 seconds is a very big difference. You don't lose your attention. Another example, you can compare React Native when it was open sourced. It was open sourced with Gradle because it was easier to start actually. But over time, we actually moved to Bug, and it's easy to see that for the same application, for the same build, we have some good results. Now, what I want to tell you is what you probably think. All right, there are some applications that build fast with Bug. But what about my application? And how much effort would it be to get rid of Gradle and start using Bug? Well, first I told you, you don't have to get rid of Gradle. There are some good use cases for keeping Gradle. But first, let me give you a few hints, because I was translating React Native from Gradle to Bug. I learned something, and I would like to share with you. First, there are some Bug simple details. But we don't have time to go deep into it. We don't have time to discuss Bug in detail. It's not a Bug talk. And it justifies to have a full session about Bug. But what you probably want to know is that Bug requires you to split your source code into trees that don't have cycles between them. This way, Bug guarantees that your caches are reliable and fast. But if we're talking about you don't need to get rid of Gradle, the thing is that Gradle resolves dependencies quite well. This is an Android application with a tree of dependencies. The yellow stars indicate that there is a conflict between dependencies somewhere on some levels. What Gradle does is, using semantic versioning or some other tools, it flattens the thing and chooses which of the dependencies it should use in the application. Bug doesn't use it. Bug doesn't do that yet because it was designed for flat repositories. And in flat repositories, you don't have tree of dependencies. So instead of getting rid of this nice tool and starting to resolve your dependencies manually, what I would recommend is write a small Gradle script. It's a task that resolves all the dependencies, downloads them, and puts them into a folder, let's say libs. And then you have a bug script written in Python. All bug configuration is written in Python. That's very simple. It iterates through the libs folder, finds all the jars, all the ARs, and then generates build rules into one large library that you can use in your bug source code. This way, I saved you a couple of days of work because it was designed for flat code base. It was designed to make you fast in your rebuild. Another thing to note is OKBug plugin for Gradle. It does something more. It actually allows you to generate bug files based on your Gradle configuration. Worth a try. So, we talked about fast iterations. Let's talk about stable iterations. Building fast is very good, but building fast and succeeding in it is much, much better. React Native is a large team. 700 people contributed to the repository. We have about 80 commits merged in the master branch every week. And at Facebook, we run master branch in our own applications. So when we accept a contribution from outside, we need to be quite sure that it doesn't break our internal apps. And we quite succeeded in having hundreds of tests running for both Android and iOS when we accept pull requests from the outside and from the inside. And I want to share a little bit of it because it's actually not that trivial as I thought when we started doing that. So could you raise hand if you are running continuous integration for Android or iOS? Well done. So not everyone raised hands, so I'll share some insights. Continuous integration is a hard job. It's actually maintaining some virtual machine and making sure that it doesn't fail and succeeds. But continuous integration for mobile platforms is even harder. You have gigabytes of SDK to download or to place somewhere to be able to compile your application. You have emulators that are slow and require a lot of memory and limit you. And iOS tests can only run on a computer produced by Apple. So you cannot spin up some continuous integration Apple system in AWS cloud. People build business around doing continuous integration for other people. When we open sourced React Native and started running tests for the open source people, we didn't consider maintaining our own CI system. It's damn hard. So, iOS tests, what we found, it was quite straight, slightly bumpy road from time to time, but tools usually are consistent. Android is a different thing. Yeah, you know. Android, the problem with Android is that it's a much wider ecosystem with no clear leader who owns which tools. Sometimes they compete, sometimes they are not supported as much as you would want. Sometimes they use a little bit too much memory. So the rest of this part, I will mostly talk about Android and a little bit in general. This is what I have seen a lot when we just open sourced our unit tests. This red thing means it's a crash. And CI system is very nice. It says it's a native crash. What it means that it stops your execution and says, oops, good luck next time. Try debugging this. The problem is that you cannot always debug it because sometimes these crashes happen what you might think randomly. This usually happens when a tool tries to allocate more memory than the VM that is running it is actually allowed. Once you go above the limit, it gets a crash. So what we found out is that limiting the tools significantly, this is what keeps it more or less stable. A lot of people on the online recommend limiting Gradle to 1 or 2 gigabytes. What we found is that 500 megabytes is actually a better bet. Also note, a lot of tools have a threads or number of cores or number of workers setting. This is important to note, because those tools are designed to work on your dev machine. It is supposed that you can have a large machine with a lot of RAM. The problem is that your CI system usually doesn't have as much memory, and it may spin up as many workers, as many cores you have on the system. Usually it's about 8. And even if you have a light tool that takes 100 megabytes, if you run it in 8 threads, it could be a gigabyte. Another thing we found out is that when you run in Gradle especially, but it's general for the build rules, when you run build steps in multiple steps, usually you run them, usually they're grouped. For example, you often repeat compile, install, and run your end-to-end tests. And sometimes you have a very convenient method to run it in one command. But the problem is that this command is long-living. Long-living commands tend to accumulate memory because garbage collection is not called at the right time, or some memory leak is possible. What we found out is that splitting the command into simple, small, short-living steps increases our reliability. And also we found out that running end-to-end tests with low-level ADB shell command is more reliable than running it within a wrapper. So let's talk about shell. Shell is amazing. Shell is everywhere. Shell can do everything, but it doesn't mean that shell should do everything. This is a Stack Overflow answer that I found how you iterate through command line arguments of a shell script. So it has a while loop, it has case, it has double semicolon for some reason, it has a winky face, and the shifts everywhere. I can't read it. I'm not that smart. I love JavaScript, but there is a problem. You may notice that there is a pattern in the code here. What we call it, it's pyramid of doom. So the problem is that Node.js is designed to be asynchronous. It's not designed to run long-running synchronous tasks because it's single-threaded. And most of the commands have callbacks, and then you need to call a callback inside a callback. And here I even tried to flatten it a little bit with Promise API, but because sometimes you need to negotiate error handling, it still goes into pyramid. What we found out, there is an amazing tool called ShellJS. It brings both shell scripting and JavaScript together. So you can run your Node program and have your imperative JavaScript language, but at the same time you can have shell scripts and execute your favorite Git commands. For example, in CI you may want to zip all logs and send them to S3, or you may want to move your APK file somewhere and deploy it to some deployment platform. So ShellJS really improved our readability of our code. There are a few good practices on the internet that you may want to try, or you probably already tried them. So give them a go. They were quite useful for us. So my final thought is development is all about iterations on small levels and on big levels. And as long as you can keep iterations running, you can keep them small, you can succeed. Do you have any questions?
Thank you, Konstantin. I have the first one, if I may try. Can I steal this slide with moving toilet and the product owner to use in my own presentations?
Definitely.
Thank you. And the second, quite nasty, is could you advise us when not to use React Native?
Oh,
I know it's a nasty question, but for sure there are scenarios that you are aware that's better not to try.
Mm-hmm.
Then we'll go to the technical questions most likely.
All right, that's a good question. When you feel very good about your native framework, when you really know what to do and you have a lot of experience with it, React Native may feel like a third leg to you. It can slow you down because it does declarative style programming. And it's different and it's in abstractions. Sometimes abstractions leak, sometimes abstractions don't work as you intend to. There is a lot of debate about React JavaScript sometimes because people want to use it not as it's designed. They want to put state in the components because they're used to the imperative style of programming. So I guess it's all up to you. React Native gives you a lot of speed in your development. It gives you React style programming with declarative type of programming, but you give up what you have learned if you have learned a lot about your native platforms. Saying that, you don't have to go to React Native full application. A lot of companies are using just pieces of React Native when they are trying or when something is really complex and needs to be done in full native.